Toastmasters and fellow members and guests. I walked into a bar the other day, and the bartender was going to pour me a drink. He gave me a nice glass. And have you ever noticed when you go into the bar, they put the napkin down, and then they give you some ice, and a nice dry glass, and then they pour the drink. Well, I was in kind of a bad mood, like, what? Why do you have to put the glass down, the paper down? You think I don't know how to drink, that I'm a sloppy person? And the guy looked at me funny, and he said, don't you know that 100 million years from now, the sun will swallow the earth? Doesn't that make all your other troubles seem so small? He said, oh yeah, that's right. 100 million years. And I thought about it later. 100 million years, that's a long time. And I think I can't imagine 100 million years. It's too big. In fact, I think that we grew up in a small society with maybe 50 or 100 people around, and really I can only imagine about 50 in my mind if I really want to think about it. And I certainly can't imagine how small things get if I look to that number. Actually, we kind of live in a world in which there's things that are so big and things that are so small, and we live right in the middle. Here. Oops. We live here. But so big and so small. And the rest, we experience this world, but we live in the other world. And yet we don't really know it's there. But if we look around, there are some clues that we can get. Of course, science, but we can also experience some clues about this big world and this small world that we live in, but we're not aware of. And today I want to talk about two of them. One is called evaporation and condensation.Maybe you studied about them in physics class. On the micro scale, the little molecules actually they act like billiard balls, pool balls, going around and following very simple rules of physics. It's not too complicated to understand. And if two balls hit each other, we might say that one ball might go faster, the other slower, or they might stay the same. Those are the different possibilities. And the interesting thing about the micro world and the normal world that we live in is that in the micro world, speed, how fast things go, is actually in our world is temperature. So the faster something goes in the micro world, the hotter it is in our world. And you can kind of see that when water is boiling. And as it starts to boil, it seems to be moving around faster. So imagine that two particles, two molecules are going, one's going at 8 and one's going at 6. And then they collide, and at the end, one will go 12 and one will go 2. So you might maybe not understand how is that possible. So let me just give a little demonstration. Two molecules, and watch this one, how fast it may go. Isn't that cool? Two molecules, one may go really fast. This one was going a little bit slower. So what's that mean? Before I talk about that, there's also a kind of force between molecules, an electrical force. That water drop should fall because of gravity, but it doesn't want to fall because there's some attraction from the other water molecules. So let's look at this case here. We have two molecules, one going 8, one going 6, and they collide, and the one is going, at the end, is going 12, just like that ping pong ball. That 12 is enough to escape the 10 that's holding it here. So what happens is that evaporation, it is losing 12 units here of energy. That means that evaporation is a cooling process. The thing gets colder. We can see that. We can understand it. It's not too hard to understand. And if we look at some different things how do we know about that? Oops. Well, is anybody feeling a little bit warm right now? Oh, okay, so up. How do you feel? squirt yourself in some water, you're going to feel really quite cool. Because immediately the water will evaporate. How do you feel? Cool, right? Or if you want to try it at your desk, just go ahead and lick yourself and blow on it. And you will feel cool. Nobody wants to lick themselves. When I was in Japan, Yaomi, I was in Japan, I saw people on a hot day walking around like this, and this was wet. And it's a very effective way to keep cool in the summer. It looks funny, but it works. And of course you all know putting your clothes out to dry. That's evaporation. It's very simple. Well, let's look at another process, which is, imagine there's a molecule floating around in the air, and it's going 12. And it comes down to the table, and it hits another molecule going 2. And because of the way they hit, the one slows down to 8, and the other one is at 6, gains some energy. No change in energy, but now this has gained 12 units of energy. And we can see that condensation is a warming process. What are some effects of that? Well, how about this? If I have some glasses, what's this trick? Maybe you can see it. Condensation, and if I wait a minute, it goes away, evaporation. Also, when you take a shower, if you stay in the shower room, you'll be quite warm. And that's the condensation that's coming on you. As soon as you step out of the shower, you're going to get cold. And maybe there's enough time that we can see that this is quite wet. Can you feel? Is it wet? But I didn't spill it. That's why they put the napkin. Because of condensation, it's going to run down and it's going to be wet, even if you're a good drinker. So let's just say that we live in a macro world, we live in a medium world, and we live in a micro world. We are more than we know. I'd like to divide the group into 2 parts. This is evaporation, this is condensation. Okay, repeat after me. Evaporation, it's cool. Evaporation.
It's cool.
Condensation. Evaporation.
Cool.
Condensation. Thank you.